solve for x. Now for this problem, I have exponentials on both sides of the equation. To add on to that, 9, I can't rewrite it in base 27, and the 27, I cannot write it in base 9, which means that I'm going to have to find a common base. I know that 9 and 27, they share a factor of 3. So I'm going to look for 3 and rewrite both of them in base 3. So let's begin with 9. 9, I can rewrite it as 3 squared. Base 3, exponent 2. So I'm going to begin by grabbing 9 and rewriting it as 3 raised to the second power. Now notice that my exponent is 2x minus 1. So here, I'm going to have 2x minus 1. I need to multiply my new exponent of 2 with the original exponent of 2x minus 1 due to that product rule. We're going to apply the same thing with 27 raised to the x power. Now 27, I notice that 27, I can rewrite it with base 3 and exponent 3. And I get 3 to the third power. And since we're going to exponentiate that to x, we're just going to get 3 times x. So we have 3 to the 3x. Now that I have the same base, I can compare the exponents, the new exponents. So 2 quantity 2x minus 1 equal to 3x. So let's go ahead and write that down. And now I need to solve for x. I'm going to begin by distributing the 2 on the left-hand side. So 2 times 2x, that's going to be 4x. And then 2 times negative 1, I'm going to get a negative 2. On the right side, I still have 3x. Whenever I have x's on both sides of the equation, I need to group them together. So here I am going to add 2 to the other side. And on the left-hand side, I'm left with 4x. On the right-hand side, I'm left with 3x plus 2. Since they are not like terms, I cannot combine them to form something else. It's at this point that I'm going to put the x's to one side by subtracting 3x from both sides of this equation. And on the right-hand side, the x's cancel out. On the left-hand side, 4x minus 3x is just x. And my result is 2. So x is equal to 2.